I said that a variable has to be something that can vary. Anything that doesn't vary and is always the same is not a variable. Let's think of an example of something that isn't a variable. If I was asking each of my participants, how many birthdays do you have per year, each person would say 1. If I kept asking more and more people this question, each person would say 1 all the way down, because each person only has 1 birthday per year. So number of birthdays per year wouldn't be a variable because it isn't something that varies across different people. Now we'll talk about different types of variables. The two major types of variables are quantitative variables and qualitative variables. A quantitative variable is a variable in which each data value stands for a number or an amount of something. Here are some examples of quantitative variables. Each time I record a person's height, I'm recording an amount of height. Each time I record a person's age, I'm recording an amount of age. Each time I record a person's income, I'm recording an amount of income. That's why these are all quantitative variables. The opposite of a quantitative variable is a qualitative variable. A qualitative variable is a variable in which each data value shows membership in a category. Here are some examples of qualitative variables. There's no such thing as an amount of gender. If a person tells me that he is a male, then that just means that the person is a member of a certain category of people. Also, there's no such thing as an amount of college major. If a person tells me that he or she is a psychology major, then that just means that the person is a member of a certain category of people. So, gender, ethnicity, hair color, and college major would be 4 different qualitative variables. Basically, quantitative variables involve amounts of things, and qualitative variables involve types of things. Let's look at an example of a spreadsheet and try to find out which variables are quantitative and which variables are qualitative. Hair color is a qualitative variable because each of these values is a type of hair color. It's not each value isn't an amount of hair color. So hair color is qualitative. What about grade level? Well, each of these values isn't a specific amount of something. It's just a category. It's a category of college students. So freshman is one type of college student, sophomore is another type of college student, and junior is another type of college student. So grade level is qualitative. Hair color and grade level are both qualitative variables because the values in those columns are types of things, they aren't amounts of things. Number of siblings would be a quantitative variable because each of these values is a specific number of something. It's a quantity of something. What about shoe size? Shoe size is also quantitative because, well, I think that a shoe size is actually the number of inches that the shoe is long. So I think a shoe that's 12 is 12 inches long, and a shoe that's size 15 is 15 inches long. So I'm pretty sure that shoe sizes are an amount of something. So shoe size is also quantitative. Commute distance is also quantitative. Each of these values is a certain person's amount of commute distance. So you have 2 qualitative variables and 3 quantitative variables. You might be thinking that if the data values are words, then the variable is qualitative, and if the data values are numbers, then the variable is quantitative. That's often true, but that's not always true because there are some exceptions. There are some numbers that actually don't stand for a number or amount of anything. For example, if I was recording each person's student ID number, and I had a student ID number column, then that wouldn't be a quantitative variable because A student ID number doesn't stand for a number or an amount of anything. If I was recording each person's social security number, I don't think social security number would be a quantitative variable, because a social security number doesn't stand for an amount of anything. At least I don't think so. So if the values are just meaningless numbers that don't stand for an amount of anything, then the variable isn't quantitative, it's actually qualitative. So variables like employee ID number, student ID number, phone number, those are all qualitative variables. Now we'll cover two types of quantitative variables and two types of qualitative variables. The two major types of quantitative variables are discrete variables and continuous variables. A discrete variable has a limited number of possible values with gaps in between the possible values. And a continuous variable is a quantitative variable with no gaps in between the possible values. I think the difference between discrete and continuous will make a little bit more sense once we start looking at some examples. Let's start by looking at the variable of number of siblings. So let's think about what the possible numbers of siblings are that a person could have. A person could have 0 siblings, a person could have 1 sibling, or a person could have 2 or 3 siblings. But a person can't have a number of siblings in between those numbers. For example, a person couldn't have 0.3 siblings right here, or 0.7 siblings, or 1.2 siblings. So each of these whole numbers is a possible number of siblings that a person could have, but nothing in between those values is possible. The number of siblings that a person has to be a whole number. I marked off the possible values in green, and I marked off the areas of the number line that aren't possible in red. The red areas are the gaps in between the possible values. So since there are these gaps between the possible values, the variable is discrete. Number of siblings is a discrete variable. What about so right here I said that this is an area where there can't be any values in here. Here's another area where you can't have any values, and here's another area why you can't have any values. Since there's these gap areas in which no values can fall, number of siblings is a discrete variable. What about the variable number of bathrooms in a house? Well, a house can have 1 bathroom. A house can have 1.5 or 1.5 bathrooms if one bathroom is a full bathroom and the other bathroom is a half bathroom with no shower or bath. A house can also have 2, 2.5 or 3 bathrooms, but nothing in between those values is possible. For example, there's no such thing as a quarter bathroom, so a house couldn't have 1.25 bathrooms right here. A house also can't have 1.3, 1.9, or 2.2 bathrooms. So once again, I marked off the possible values in green, and I marked off the areas of the number line that aren't possible in red. The red areas are the gaps in between the possible values. And since we have these gaps in between the possible values where no values can fall, number of siblings is a discrete variable. The reason why I used green to mark off the possible values and red to mark off the areas that aren't possible is because green is it's like a green light, where green means go, and you can have a value there, and red is like a red light, meaning stop, where you can't have any values in there. That's why I decided to use red and green. When a variable is discrete, the possible values are like stepping stones with gaps in between. You can imagine that everyone in the world who has one sibling is stacked above this value right here, because they all have one sibling. Everyone in the world who has two siblings is stacked above this value right here. And everyone in the world who has three siblings is stacked above this value right here. So when a variable is discrete, the possible values are like stepping stones, and a person has to stand on one of the stepping stones, and a person can't stand anywhere between the stepping stones. What about variables involving dollar amounts? A person could spend 1 cent, 2 cents, or 3 cents on something, but a person usually isn't able to spend an amount of money in between those values. For example, a person isn't usually able to spend 0.012 cents or 0.027 cents on something, unless they're buying gas, I guess. So variables involving dollar amounts, like income, account balance, or amount of money spent on food, are typically discrete variables. Discrete variables are usually variables that are counted. For example, a person could count his or her number of siblings. A person could count the number of bathrooms in a house, and a person could count the amount of money in a jar of coins. The other type of quantitative variable is called a continuous variable. And we said that a continuous variable is a quantitative variable with no gaps in between the possible values. I said that a discrete variable is usually something that's counted. A continuous variable is a quantitative variable that's measured. And when you measure something, you can theoretically get any value. Let's think about what values are possible when you measure someone's height. A person's height could come out to a nice number like 50 inches or 51 inches, but a person's height could, in theory, come out to any number in between. For example, a person's height could come out to 50.145 inches, to 50.1455 inches, or even 50.14555 inches. The number of decimal points that you would end up with would depend on how exact of a measurement you're making. When you measure a continuous variable like height, you decide how exact of a measurement you want to make. For example, you could measure a person's height in inches, centimeters, millimeters, or something even more exact. When you measure a continuous variable, your measurement will only be so exact, but the measurement could theoretically come out to any number. There might be a limit on how low the value can be, or a limit on how high the value could be, but anything in between is a possible value. For example, when you're measuring a person's height, there might be a limit on how short a person could be, and a limit on how tall a person could be, but anything in between is a possible value for a person's height. Since any height along this number line is possible, I marked off the entire number line in green. For each of the discrete variables, I marked off the possible values in green, and I marked off the areas of the number line that weren't possible in red. Since any value along this number line is a possible height, I marked off the entire number line in green. There aren't any red areas because every spot on this number line is a possible height. There are no gaps between the possible values, which is why it's a continuous variable. Temperature is also a continuous variable with no gaps in between the possible values. There might be a limit to how cold it can be, and a limit to how hot it can be, but anything in between is a possible temperature. For example, on a certain day, it could be 70.738942 degrees outside. Since any temperature is possible, and there's no gaps between the possible values, I marked off the entire number line in green. Think about this. When you measure a person's height with a sliding scale, like they do at a doctor's office, the scale moves smoothly across the possible values. If height was a discrete variable, the scale would jump from one possible height to the next possible height. Also, think about the type of thermometer that has a stick that moves up and down. If temperature was a discrete variable, then that stick should jump from one value up to the next value as it gets hotter, and it should jump down from one value to the next value as it gets colder. But that doesn't happen. As it gets hotter, the stick smoothly rises up, and as it gets colder, it smoothly drops down. So temperature is a continuous variable. The word discrete means broken into separate pieces. So when a variable is discrete, each possible value is a tick mark that's separated from all of the other tick marks by these red gap areas. So the possible values are broken into these different pieces. When something is continuous, it continues forward without any gaps or breaks. So a discrete variable has possible values that are like stepping stones, and a continuous variable is like a smooth sidewalk, because any value is possible. There's no place where a value isn't possible. We've talked about the two types of quantitative variables. Now we can talk about the two types of qualitative variables. Remember that a qualitative variable involves types of things, or categories. One type of qualitative variable is called an ordinal variable. An ordinal variable is a qualitative variable in which the possible categories follow in order from lowest to highest. Grade level is an ordinal variable because the possible categories follow the order of freshman, sophomore, junior, and senior. Socioeconomic status is an ordinal variable because the possible categories follow the order of lower, middle, and upper class. So an ordinal variable has possible categories that follow in order from the lowest category up to the highest category. Any type of variable involving status is an ordinal variable. Job status is an ordinal variable because a company might have lower, middle, and upper managers. Rank in the military is an ordinal variable. Status in martial arts would also be an ordinal variable because at the bottom you might have a yellow sash, and then as you go up you might have a blue sash, a red sash, a brown sash, and a black sash. So there are ordinal variables involving levels of achievement. For example, in the Olympics, you have bronze, silver, and gold medal winners. Highest level of education would also be an ordinal variable because you have categories like AA, BA, Masters, and PhD. There's also ordinal variables involving level of difficulty. For example, difficulty of a ski lift would be an ordinal variable with the possible categories of circle, square, diamond, double diamond, and triple diamond. Circle is the easiest and triple diamond is the hardest. Sometimes a researcher will record information about something that's actually quantitative, but will record each data value as a category instead of as a number. For example, age in years is a quantitative variable. Instead of recording people's ages in years, a researcher might decide to simply record whether each person is a child, an adolescent, or an adult. In that situation, age becomes an ordinal variable. Age in years is a quantitative variable, but age group is an ordinal variable. One thing that makes an ordinal variable different than a quantitative variable is the fact that an ordinal variable doesn't always have equal spacing in between the possible values. For example, cup sizes and ounces are always equally spaced. The difference between 10 and 11 ounces is the same as the difference between 11 and 12 ounces, and the difference between 12 and 13 ounces is also the same. But cup size categories like small, medium, and large aren't always equally spaced. For example, at a certain restaurant, small might be 10 ounces, medium might be 12 ounces, and large might be 20 ounces, and those three categories aren't equally spaced. Also, shirt sizes like small, medium, large, and extra large aren't always equally spaced. A salsa company might sell types of salsa with names like mild, medium, hot, and fire. Fire is probably a lot hotter than the other three types of salsa. So mild, medium, and hot are probably closer together, and fire is probably a lot hotter than the other three. Here's two other points about ordinal variables. An ordinal variable doesn't have to be a variable in which a person starts at the lowest category and then moves up. For example, we know that a person has to start college as a freshman and then move up to being a sophomore, a junior, and a senior. But in the Olympics, a person doesn't have to win a bronze medal first before winning a gold medal. A person could win a gold medal first before winning any other type of medal. So an ordinal variable isn't always a variable in which a person starts at the lowest category and then moves up. Also, when you look at different types of ordinal variables, you'll notice that higher categories aren't always better than lower categories necessarily. For example, it might be considered better to win a gold medal than to win a bronze medal, but it isn't better to be an adult than to be an adolescent or a child. It just happens to be that adult is a higher category than adolescent or child. So an ordinal variable just has to be a variable in which the categories follow in order from the lowest category up to the highest category. The opposite of an ordinal variable is a nominal variable. So ordinal and nominal variables are the two types of qualitative variables. We said that an ordinal variable is a variable in which the possible categories follow in order from lowest to highest. A nominal variable is a qualitative variable in which the categories don't follow in order, and all categories are considered equal. A nominal variable simply involves different types of things. So variables like gender and ethnicity, or hair color and college major are nominal variables. Here's a picture right here. Each of these four variables, grade level, socioeconomic status, shirt size, and highest education, are ordinal variables. And when a variable is ordinal, the possible categories follow in order from lowest to highest. When a variable is nominal, the possible categories are all equal. They don't follow an official order that everyone agrees on.